Pro Electrician, number 4. Chapter 4, Electrical Prints, Specifications, and Codes. Technical terms for the chapter are detailed drawing, elementary diagram, elevation, informational notes, International Association of Electrical Inspectors, or IAEI, lighting plan, model code, National Electrical Code, or NEC, National Fire Protection Association, NFPA, Occupational Safety and Health Administration, OSHA, one-line diagram, plan, power plan, schedule, schematic diagram, section, single line diagram, and specifications. The objectives for the chapter are to describe several types of electrical drawings, identify common electrical symbols, explain the purpose of specifications, explain the importance of building codes, define the purpose, intent, arrangement, and key terminology of the National Electrical Code, name various agencies that set standards concerning electrical practices and procedures, and finally identify various lab facilities that perform rigorous testing of electrical devices, equipment, and associated components for safety and performance certification. Engineers, architects, and designers use drawings to communicate construction details to those performing the work. In order for an electrician or in order for an electrical system to be installed properly, several types of drawings and diagrams are used. Some drawings specify what is being installed and where it is being installed. Other types of diagrams show how the device is installed. Electricians must be familiar with all types of electrical drawings and commonly used electrical symbols. In addition to drawings, every construction project has a set of specifications. These specifications contain detailed instructions for construction procedures, requirements, and materials. All work performed on a project must conform to the specifications. Therefore, specifications are as important as drawings to the successful completion of a project. Specifications normally list the building code that the project must satisfy. Inspectors periodically check the site to ensure that the codes are being obeyed. Many local building codes mandate that electrical work conforms to the National Electrical Code, that's the NEC. This text is based on the requirements of that code. Electrical print reading. Electrical drawings show device locations and identify materials needed for an electrical installation. Drawings can also be used to show individual connections to provide a simplified view of a circuit. Standard symbols are used on drawings to represent devices and equipment. Electrical drawings are useful not only to the electrician installing the system but to others as well. Estimators use drawings to prepare bids. Maintenance personnel use drawings to troubleshoot and repair problems. Purchasers use drawings to determine the materials to order. Manufacturers use drawings to fabricate equipment. Everyone involved in the construction process must be able to read drawings. The construction drawings. A typical set of drawings used in constructing an electrical system have plans, elevations, sections, and details. These 4 types of drawings are used throughout the construction and in all building trades. Plans are drawings showing the project viewed from above. These drawings normally contain more information than the other types of drawings. Elevations show the side view of an area or object. An elevation is provided when the plan view cannot provide the information clearly. By studying both the plan and elevation for an area, you can visualize the construction in 3 dimensions. In situations where a detail cannot be shown clearly in the plan or in the elevation, a sectional drawing is used. Sectional drawings or sections are elevations that cut through an object or building. The location of the slice is made or is marked on the plan with a section line. All items to one side of the section line are removed from the sectional drawing. This allows internal or hidden items to be shown. Detailed drawings show a particular device, item, or parts of the system that cannot be clearly shown in a plan, elevation, or section. Detailed drawings often have a larger scale than other drawings. This allows the designer to detail or enlarge small items. The location of the detail is shown on a plan, elevation, or section. Electrical symbols and abbreviations. Symbols and abbreviations are used on drawings to simply represent the type, size, and style of equipment to be installed. Anyone using electrical drawings must have a knowledge of the symbols and abbreviations in order to understand and interpret the drawing. Note, shown on the screen, although symbols are somewhat standardized, standard symbols are not used universally. Different designers may use different symbols to represent the same item. Therefore, always refer to the symbol legend on the drawing. The symbols represented in this chapter are based on the ANSI or ANSI Y32.9 from 1972. Graphic symbols for electrical wiring and layout diagrams used in architecture and building construction, which is prepared by the American National Standards Institute or ANSI. Wiring symbols. Electrical plans do not show exact location of conduit runs. However, conductors that connect devices are shown as irregular arcs. These arcs are dashed when the conductors are concealed in the floor and solid when the conductors are in the ceiling or walls. The number of conductors in a conduit run is shown by small marks across the conduit line or the conduit run line, shown as full marks, or hot wires are shown as full marks. Often neutral wires are shown as half marks, which may be centered on the line or entirely to one side. See figure 4-1 in the text to see this. Circuits without conductor marks are assumed to have two hot conductors. If all the circuit lines are drawn back to the panel, the drawing would be very crowded. Therefore, an arrow at the end of the conduit line signifies a conduit run back to the panel. Normally, the panel and circuit is identified next to the arrow. The number of arrows at the end of a conduit line indicates the number of circuits whose conductors are contained in the conduit. For this, see figure 4-2 in the text. Lighting symbols. Switches, lighting outlets, and fixtures are normally shown on the electrical plan. Switches are identified by the S symbol perpendicular to the wall where the switch is located. Sometimes a line is drawn through the S and touching the wall. Subscript letters and numbers are added to identify various types of switches. Figure 4-3 shows some of these. Symbols used for lighting, outlets, and fixtures may vary. Some standard symbols are shown in figure 4-4, shown on the screen now. Normally, each fixture symbol is accompanied by a letter corresponding to the mark in the lighting fixture schedule. The schedule provides the exact type of fixture and lamps. Receptacle symbols. Symbols on the electrical plan identify the locations and types of receptacles. Special or unusual receptacles are clearly marked. Circuit lines may be used to show the connections between the receptacles. See figure 4-5 on the screen now. Additional symbols. Other standard electrical symbols are shown in figure 4-6 on the screen. These symbols can be used in any type of electrical drawing. Becoming familiar with these common symbols will improve your print reading skills. Categories of electrical drawings. There are several types of electrical diagrams and drawings. The type of drawing used is determined by what the drawing intends to show. The following are some of the most common types of electrical drawings: electrical plans, schematic diagrams or elementary diagrams, single line drawings or one line diagrams, and schedules. Electrical plans. Electrical plans show the basic floor plan, walls, doors, windows, and stairs, along with the installed electrical devices. For small projects, a single electrical plan may be sufficient to show all of the electrical equipment and connections. However, for most commercial projects, two electrical plans are used. See figure 4-7. An electrical lighting plan shows switches, lighting outlets, and fixtures, and the conductors connecting them. An electrical power plan shows the receptacle, outlets, and equipment with electrical feeds. Panels are often shown on both types of plans. Electrical plans include marks that reference schedules, elevations, sections, and detailed drawings. Other types of electrical diagrams are used to help clarify circuits and connections. That is a continuation of figure 4-7, which shows the power plan. Electrical schedules. Electrical schedules are tables that list items such as fixtures, power requirements, panel board information, receptacles, transformers, and motors. Schedules save print reading time by placing information in one easy to find location. This helps with project estimating, purchasing, and construction. The following are some examples of schedules. Lighting fixture schedule. This type of schedule lists the lighting fixtures used in the project. See figure 4-8. Each row in the schedule lists basic information of a single type of fixture. The information includes the number of fixtures required, the manufacturer, model number, and number of types of lamps. Each type of fixture or lighting fixture also has a unique mark, normally identified with a letter. The marks, which are included on the lighting plan, identify the location of the fixtures. Equipment schedule. An equipment schedule lists the large electrical equipment being installed. The information provided in this schedule varies depending on the specific type of equipment listed. Equipment schedules may include the voltage provided to the equipment, size and type of overcurrent protection, and the number and sizes of conductors feeding the equipment. Motors, heating units, and cooling units are often listed in equipment schedules. Panel schedules. A panel schedule, figure 4-9 on the screen now, lists the basic characteristics of a lighting or power panel. The information normally includes the panel voltage, panel amperage rating, and a chart listing the circuits, circuit breakers, and equipment served by each circuit. Miscellaneous schedules. The size of the project determines the number and size of schedules. For large projects, schedules may be included to aid estimating and purchasing. A receptacle schedule and a switch schedule may be included. These schedules are similar to a lighting fixture schedule. Schematic diagrams. Schematic diagrams, also called elementary diagrams, show the arrangement and connection within a circuit. These diagrams show the function and order of the items in a circuit without specifying device size or location. Single line diagrams. Single line diagrams use single lines and symbols to show the course of a circuit and its components. These diagrams are also called one-line diagrams. An example is shown in figure 4-10, shown on the screen now. Electrical specifications. Specifications are the written detailed description of the project requirements. The specifications are essential along with the set of construction drawings to complete the contractual obligations of an electrical construction project. Many specifications are arranged using the Construction Specification Institute's master format. Specification writers use this numbering system to organize the various tasks involved in a construction project. The master format consists of many divisions, each addressing a general construction topic. Some of these divisions are listed in figure 4-11, shown on the screen. Within the master format, electrical work is found in division 26. The see figure 4-12 for this. Specific electrical topics are addressed within sections of the division. A complete list of divisions and sections is in the master format reference on page 231. Building codes. Localities adopt building codes to ensure that a building meets a specified quality and level of safety. Code requirements make a building safer in the event of a natural disaster, for example, such as a fire, flood, or earthquake. The intention of building codes is to prevent injury and loss of life and reduce building damage when the building is subjected to the forces of nature. Building code requirements tend to be more strict for buildings designed for public use. Building codes address the types of construction methods and materials that can be used. Unspecified materials and methods are acceptable if they are approved by the proper authority. Codes will also specify specific materials and methods that are unacceptable for a given type of construction. Many building codes specify model codes to be followed. Model codes are extensive codes established by national organizations. The organization that establishes model code continually researchers the organization that establishes the model code continually researches and updates the code to incorporate new technology, materials, and methods. The model electrical code used throughout the United States is the National Electrical Code. Most local building codes require work to be performed according to this model code. The local codes may include additional requirements in specific areas. The National Electrical Code. The National Electrical Code, or the Code or NEC, governs nearly all electrical construction performed in the United States. There is no national law that requires electrical construction to conform to the code, but most building codes mandate code compliance. The first code was prepared in 1897. In 1911, the code became more formally organized under the administrative sponsorship of the National Fire Protection Association, NFPA. The present format of the code was set up in 1959. Using article numbers preceding section numbers, a revised edition is issued every 3 years. Code content and arrangement. The code consists of an introduction of 9 chapters. These chapters are divided into 4 sections. General installations. Chapters 1 through 4. Chapter 1 defines the terms you will need to know to understand the code. Chapter 2 discusses the wiring design and protection. Chapter 3 provides rules governing wiring methods. Chapter 4 covers cords, cables, fixtures, fixture wires, motors, compressors, and battery operated electric vehicles. The table in figure 4-13 lists the articles found in these chapters. And you can see that in this shot in the screen right now. Special installation or special installations, chapters 5 through 7. Chapter 5 is concerned with the areas where spark generation by electrical equipment may cause fire or explosion due to volatile atmosphere or material. Chapter 6 covers the electric sign wiring, outline wiring, crane or cranes, hoists, elevators, escalators, and moving sidewalks. It also covers welding machines, sound recording equipment, X-ray equipment, and machine tool wiring. Chapter 7 deals with emergency lighting circuits. See figure 4-14 on the screen now. Communications, Chapter 8. This section contains the requirements for communication circuits, radio and television equipment, and antenna distribution systems. See figure 4-15. Tables and annexes. Chapter 9 contains many tables. The appendices the appendices contain additional information related to the code. These items are listed in figure 4-16. Within the code, chapters are divided into articles. Each article is identified with a 3-digit number. The first digit of the article identifies the chapter in which the article is located. For example, Article 300, Wiring Methods, is in the first article of Chapter 3. Each article addresses a specific topic. Most articles consist of several parts, which are identified by letters. The parts help to organize the article and make it easier for the user to locate a specific item. The parts are then divided into sections, with the sections further divided into subsections. Almost all references in the code and in this text are sections or section references. For example, a reference to section 600.5b1 of the code directs the user to subpart 1 of subsection B of section 600.5. Section 600.5 is the fifth section found in Article 600. See figure 4-17. Finding code rules. The code provides two ways to find specific information: the table of contents at the beginning of the book and the index at the end of the book. The table of contents is an overall outline of the code arranged by chapters. The chapters are listed along with their component articles. If the article has two or more parts, these are shown as well. The index is an alphabetical listing by subject matter that indicates the article and section and pages where the information is located. This is the best place to begin to search for a specific topic. The code intent within Article 90, Introduction. The purpose and scope of the code is defined. The clear intent is to provide information for the safeguarding of persons and property against electrical hazards. Compliance with the code prevents fire hazards, but will not necessarily result in an efficient system adequate for the intended use. NEC Notes 90.1C. 90.1C. The code is not intended as a design specification nor an instruction manual for untrained persons. The rules and regulations found within the code are not mandatory or legally required unless the local authority accepts the code for such purposes. The code is recognized throughout the United States, as well as many other countries, as a legal basis of safe electrical design practice. Safe electrical design and practice. It is used extensively in courts and by insurance agencies in making legal judgments. The code must be understood by all those involved in the industry. In scope, the code is applicable to almost all electrical work, both indoor and outdoors. This includes, but is not limited to residences, apartments, office buildings, industrial facilities, marinas, theaters, floating buildings, mobile homes. The code addresses not only design basics and requirements, but also addresses installation rules, equipment requirements, and product acceptability. Code enforcement. The code is mandatory in most localities. This makes it the legally required document for those involved in design and installation of electrical systems. Code enforcement is usually performed by local inspection agencies. Inspectors are authorized to interpret, modify, or waive specific code requirements. Many inspectors are members of the International Association of Electrical Inspectors, or IAEI. They have tremendous responsibility and must exercise their task with great care, consideration, and expertise. Numerous code references are made within this text. If you do not have a copy of the code, get one. Copies can be obtained at your local bookstore or directly from the National Fire Protection Association. In addition, the NFPA publishes other useful and relevant standards: NFPA 30, Flammable and Combustible Liquids Code; NFPA 70B, the Electrical Equipment Maintenance; NFPA 70E, Electrical Safety Requirements for Employee Workplaces; NFPA 72, National Fire Alarm Code; the NFPA 77, Static Electricity; NFPA 99, Healthcare Facilities; NFPA 101, Life Safety Code; and the NFPA 780, Installation of Lightning Protection Systems. Exceptions and informational notes. As with any set of rules and regulations, the code has numerous exceptions and notes that further explain or modify rules under certain conditions. Sections of the code may include exceptions and informational notes. See Figure 4-18 on the screen now. In general, exceptions reverse, modify, or eliminate a requirement under specific conditions. The informational notes serve to elaborate, enhance, and explain a code section. NAC notes: mandatory rules are indicated by the use of the terms shall or shall not. Permissive rules are characterized by the use of the terms shall be permitted or shall not be permitted. Explanatory material is indicated by the informational notes, such as this one. Significant code terms. Article 100 of the code defines key terms. These definitions should be carefully studied. Some important terms include the following: approved, which is acceptable to the authority having jurisdiction, or AHJ. Labeled, has an attached label of an organization that is the authority having jurisdiction with the product evaluation and by whose labeling the manufacturer indicates compliance with appropriate standards or performance. Listed, a product or service that either meets appropriate design standards or has been tested and found suitable for a specified purpose and are included in a list of published by an organization that is the authority having jurisdiction. See Figure 4-19. Osha Standards. The Occupational Safety and Health Administration, OSHA, under Subpart S, Part 1910 of the Code of Federal Regulations, provides design safety standards for electrical systems. This is a legal document derived from the National Electrical Code. The purpose of OSHA's electrical document is to provide a standard that secures a high degree of safety for workers by regulating the use of electrical equipment. Unlike the code, OSHA's standard relates only to personnel safety. It is not a standard for design and installation. The requirements in OSHA's regulations are applicable to all electrical installations and systems. Violations of these rules are cause for citations and fines. Everyone involved in electrical design and installation, particularly in commercial and industrial areas, must understand the OSHA standard. As part of the electrical standard, OSHA requires that electrical equipment and materials be listed, labeled, accepted, or certified, providing that such equipment is available. A non-listed, non-labeled, non-certified component may be used only if it is in a class not tested by a nationally recognized testing laboratory. Should that be the case, the object must be inspected and tested by a recognized organization. There are many nationally recognized testing laboratories: Underwriters Laboratories, Inc. or UL, the Factory Mutual Research or FM, the United States Testing Company Incorporated or UST, and the Canadian Standards Association or CSA. Figure 420 shows the typical labels used by these organizations. A product is listed only for its intended purpose and should be used only for its intended application. Also, just because one component of a piece of equipment is listed does not mean the entire item needs or meets standards. Be sure each component and the entire unit meet the minimum standard for safety. For example, a listed appliance cord does not mean the appliance itself is listed. Check the equipment to see if it has been listed as well. other standards. There are other agencies that set standards used by the electrical industry. These organizations often help to amend, enhance, and contribute to the NEC. Individuals representing these organizations are usually part of the committee that review and modify code sections. These organizations include the following: the National Electrical Manufacturers Association, or NEMA, the National Electrical Contractors Association, or NECA, the International Association of Electrical Inspectors, IAEI, the International Brotherhood of Electrical Workers, IBEW, the Institute of Electrical Electronics Engineers, the IEEE, the American National Standards Institute, ANSI, and the Illuminating Engineering Society of North America, IESNA. Shown on the screen are some of the review questions. And there are also some problems to get you familiar using the NEC. You can go through those on your own and make sure that you are familiar with the answers for each of these questions. Some of them are provided at the bottom of the screen. And do make sure that you go through the problems or questions to find within the NEC itself. Again, the NEC 2011 is needed for these problems. They do change slightly from year to year. So the one that you may have may be slightly different, but it may serve as a reference for answering at least most of these questions.